Greeting and welcome to this tutorial on object-oriented programming in Java. This time we're going to take a look at a much more complete example of object-oriented programming plus some basic inheritance and the is-a-has-a relationship. So let's get started. And we're going to start off by looking at the pet class. So this is a fairly standard class. Nothing that we haven't seen before, except for maybe the protected keyword here. We'll talk about that in a moment. But nothing we haven't seen compared to the previous video. Got public class pet. We have some properties that we are defining. We have a constructor. Notice there's no default constructor. Actually, none of these, not pet, owner, pet, dog, and cat, none of those have default constructors. You are not required to have a default constructor. A lot of objects will have a default constructor, but it is not required. And so I'm just passing in name, age, and owner. So anytime you create a pet, that pet has to have a name, the pet has to have an age, and the pet has to have an owner. You're not allowed to create a pet without that information. Now, of course, this doesn't stop the person instantiating an instance of the class from passing in bad values here. But they do have to pass something in. And we have a fairly standard selection of getters and setters. Now, we got a change name, get name, change age, get age, nothing particularly shocking. And then we have take a bath, which I am printing out. This is not defined for generic pet. Now, there's a couple of instances of this. I want to point this out here. System.error. This is actually a mistake. And there's one other point in here where I make a mistake due to autocomplete being a bit odd. I was going a little bit too fast, didn't notice that when I was doing autocomplete, that autocomplete for some reason was wanting to do system.err instead of system.out. So when you're using autocomplete, pay attention to make sure that you're selecting the correct autocomplete. In this particular case, it doesn't matter because system.out and system.err both print out to the console. All right, so that's the pet class. Nothing really super exciting going on here. Let's take a look at dogs. Dog's a little bit different. Public class dog extends pet. What this means is that a dog is a pet. Like I said, we've got this little saying that we use in OOP, is-a-has-a. Is something else, so it's an is-a relationship. So in this particular case, a dog is a pet. Dog is also an object, because you have to remember, anytime you create a class, it always extends object, even though you don't explicitly state that. So even though I don't explicitly have the extends here, if you mouse over pet, it tells you that it extends object. If I mouse over dog, it tells me that it extends pet. That means a dog is a pet, and a pet is an object. Therefore, a dog is an object. This chain, by the way, can extend as far as you want. There are performance considerations about making this chain too deep, in addition to code maintenance considerations. Having super deep inheritance chains makes maintaining that code nightmarish in terms of its difficulty. But you can have that inheritance chain go as long as you need it to go. Now, what does this mean? Well, let's skip down here for a moment and take a look at a new definition of take a bath. And notice that I am using this.name. Well, hold on. There's no name defined here, right? Well, when something's a child class of something else, that's one way of referring to it. So I could say that dog is a child class of pet, or pet is the parent class of dog. When you inherit from another class, you also inherit all of its properties and all of its methods. So even though dog does not have a name defined because it inherited pet, this is actually referring back to the name that was defined in pet. So coming back up here to our constructor, we've got a version that mirrors the parent class. That's not required, by the way. I don't have to have this. If I wanted to make it so that you're not allowed to create a dog without entering in the breed, I could just simply not have this version of the constructor in here and everything would be fine. Mainly doing this to demonstrate different constructors. So I have the name, age, and owner being passed into the dog. And then I have this odd little line here, super name, age, owner. Especially in the case of constructors. Remember, I inherit all of these methods, including this constructor. But in order to call this constructor, I don't use like new pet here. That's not at all what you would do. Instead, you use the super keyword. And by passing these in, I am calling the parent constructor like this. This is generally a very good idea to do because you don't want to recreate the parent constructor in the child class. It's like that code's already been written, that code's already been debugged, just go ahead and use it. Obviously, it's programming, right? There's always an exception to the rules. But generally speaking, in the vast number of situations, you would want to use super to call back into the parent constructor instead of recreating the parent constructor inside here. And I'm doing the same thing here with this constructor. Passing in name, breed, age, and owner. I'm calling super and passing in the name, age, and owner because that's what the super expects. And then from there, I am setting the breed information. I, of course, have setters and getters for the breed, as one should. And then take a bath and toString are interesting. Ignore the warnings. If you mouse over it, it's going to complain that you should add the override annotation. You don't have to. That's just Visual Studio being exceptionally persnickety about formality. This is perfectly acceptable. And in fact, most Java code you will see is written like this without the override notation. We'll deal with notations later. We have take a bath. We also have take a bath in the parent class. Well, I'm overloading that function. It has the exact same signature. Remember, for main functions on overloading. So I am overloading my parent's method. So that way when an instance of a dog calls take a bath, we will use this version, not this version. Now, what take a bath doing is nothing particularly interesting. We're checking to see if the name of the breed is husky, and if it is, it's going to howl the song of its people. Otherwise, the dog just pants and looks at you. I do want to take a quick moment to talk about this check here and how it differs from cat and some of the other checks. If this.breed.toLowerCase.equals. So what's going on here? Of course, breed is the string that contains the breed information. All strings have a .toLowerCase method that will take that string, make sure all the letters are lowercase, and then return that modified string back. It does not change the original string. We'll see that in action when we run this. Even after a bath has been taken, the animal's name will still be their breed will still be capitalized, I should say, if it was capitalized originally. So this does not modify the original string. And then Java prefers that you use the dot equals method to compare strings rather than the comparison operator. You can use the comparison operator. It is perfectly legal. It's just Visual Studio will whine at you if you do so. That's what's going on there. And then we'll see an alternate version of that when we take a look at cat here in a moment. Let's talk about toString. toString is also an override. As you can tell here by mousing over it, it'll complain to you, add the override notation. No, I will not. But this comes from object. So the object class has toString defined on it, which means every object has it, even pet, even though I did not explicitly define a toString here, because it inherited object, it inherited object's toString, so toString will work on pet. Not well, as we'll see, but it does work. But here I'm overloading it, overriding it, I should say. Use the correct words. I'm overriding it, so that way if I have an instance of a dog and I call toString, this is the code that will be called. It is generally considered good practice when you have a custom class to define a toString so that way it returns something sensible. Because we'll see here in a moment what happens if you don't have this defined. All right, let's take a look at cat. Cat is pretty much the same as dog with some modifications. Cats also have a color pattern in addition to a breed. Now, you might be looking to say, well, wait, if cat has a breed and dog has a breed, why not just put the breed property in pet? Well, maybe every pet doesn't have a breed. Maybe, for example, in addition to dogs and cats, you're a very odd grooming salon and you also do grooming on foxes. Don't know if that's actually a thing or not, but it could be. And so if you had the fox class, you might not need the breed because a fox is a fox. At that point, it doesn't matter. They're all exotics. If you're bathing a fox, the breed doesn't really matter too much. Just as an example of why I might not want breed on every single child pet that I create. Constructors use the same pattern. We've got that constructor that mimics the parent, and then setting breed and color pattern to unknown. And then, of course, I have a version of cat that does, in fact, set the breed and the color pattern. Same collection of getters and setters for setting and getting the breed, setting and getting the color pattern. Take a bath. So this is the alternate version. Instead of using toLower, string also has an equals ignore case method that you can call instead of just calling dot equals, because dot equals is case sensitive, and that we'll see how that might potentially cause a problem a little bit later. But equals ignore case does what it says on the tin. It's going to check toStrings, but it's going to ignore any case differences. So I'm just checking to see if it's a Maine Coon. The Maine Coon's going to look annoyed while it's getting its bath. Otherwise, yeah, the cat's deploying the murder mittens and trying to escape. And again, we've got this toString here. That's just printing out the cat's information. We'll come back to the meow in a moment. It's here for a very specific example at the end of this lecture. So that's the is a chain. So again, a cat is a pet, a dog is a pet, and both dog, cat, and pet are objects because pet extends object. There is no way for you to stop that. Everything extends object. So let's look at a has a relationship. Owner does not extend anything. However, what it does have is it has an array list of pets. This is what we would call a has-a relationship. The owner isn't a pet. Rather, the owner has a pet. Another common example of when learning this concept in object-oriented programming is a car. If you were trying to model a car, you might also have classes to represent the engine, the tires, the radio system. And so you would say a car has tires. A car has an engine. You wouldn't say that a car is an engine. So this is a has-a relationship. Quick note on this. Why am I using an array list, which, by the way, you need the import java.util to do? Well, why am I using an array list instead of an array? Well, I don't know how many owners I need for when I get to the pet salon part here. And I just completely jumped ahead. I don't know how many pets I have. Ignore the previous sentence. As an owner, I don't know how many pets I'm going to have. I could have 1 pet. I could have 10 pets. I don't know. And an array in Java cannot be changed. Once you declare the number of elements an array has, that is the number of elements an array has. Now, I could declare an array of, say, 10 pets. Like, no one should have more than 10 pets. Unless maybe my client is a rescue shelter and they have 100 pets. But I don't want to declare an array of 100 pets because the vast majority of my clients are going to be individual owners, and if an individual owner has 100 animals, I'm calling animal protection. So we got a dilemma here. It's like, how do I handle this? Well, array list, if you go to W3 Schools and you scroll down to look at like the collection articles, you will find the list, array list, and linked list articles. Not officially assigned reading. Well, the array list is assigned reading. The list and linked list isn't. Still good things to read, especially the rest of the collection articles in general. But basically, an array list gives me the ability to have a list that kind of sort of behaves like an array that I can use to like add and remove things to dynamically. The little bit of an odd syntax here. Basically, an array list can be an array list of any data type, but you do have to tell it what that data type is. And so that's why I have the angled bracket pet there. This is informing the array list that its data type is pet. Now, you might be thinking, okay, well, wait, why are you creating an array of pets? Well, a dog is a pet. Therefore, I can assign an instance of a dog to a pet data type because a dog is a pet. Likewise, cat is a pet. So therefore, I can assign a cat to a pet data type because a cat is a pet. This is where you start getting into the usefulness and the absolute insanity of object-oriented programming. Because cats and dogs are both pets, cats and dogs can be stored in the same array list if that array list is an array list of pets, of type pet. I cannot store a cat and a dog reference in a dog data type because a cat is not a dog. Likewise, a dog is not a cat, so I would not be able to store a dog in a cat data type. But they are both pets, so both dogs and cats, and whatever else I decide to extend off, foxes, bears. Please don't ever think a bear is a pet. It's not. Whatever it is, if it inherits from pet, I can stuff it in here. All right, let's continue on. Public owner, pass in name, pass in address. We don't actually use the address. It was just kind of there. Set the values and create a new array list. Remember, anytime you're dealing with objects, with the exception of the string, because a string is weird and special. But if it is an object, you have to have the new keyword. It's an array list. Array list is an object. I have the new keyword. Owner, new owner. Cat, new cat. Dog, new dog. You get the point. Remember, anytime you've got that object, you need to use the new keyword somewhere. Somewhere a new instance has to be created. Ye old standard set of getters and setters. Nothing special going on here. We have a couple of interesting methods here. First, get all pets. There could be a variety of reasons as to why I need to query the owner and say, hey, give me all of your pets. And so I just simply say return pets. This does not create a copy. We'll see a clearer example of this later. But by saying return pets, or when I say get pet by name and I return a pet, I am not returning copies. I'm returning pointers. We'll have like I said, we'll have a clearer example of that towards the end. So here I'm just saying, yep, fine, here, have all the pets. And here I'm looking up a pet by name. So I'm passing in a name and saying, okay, well, I'm going to set up my result to be null because I might not find this pet. If I pass in, maybe there's a typo in the name, or just I misremember. It's like I'm looking up Bob's pet, but I'm trying to look up Bob's pet on Jane. Oops, that's not going to work. And so there's a chance that I won't find anything, which means I'm going to return null. Null is the special keyword to indicate that nothing exists. So pet result, again, I'm saying result is of data type pet, but as of this moment, it does not exist. There's sort of always an implied, and again, do not make this change. There is always sort of this implied equals null whenever you declare a variable of a class. So there is an implied pets equals null right here. Here, I'm just making it explicit. Pet result equals null. And then I'm going to use ye old standard for loop to cycle through my array list. I have to use get instead of angle or square brackets to get my elements, but that's fine. So I'm going to use get here. I'm going to get the pet. Once I've gotten the pet, I'm going to get the pet's name. I'm going to use equals and check it against the name that was passed in. If it matches, I'm going to get the pet again, store that in result, and I'm done. There should not be a duplicate pet, so I'm going to break out of the for loop and then return what I found, whether I found a pet or I didn't find a pet, and I return null. So some things about this method. One, it's already mentioned. We are hard assuming, there's a hard limit here of an owner cannot have two pets with the same name, which generally shouldn't happen anyways, but you always want to be aware of the assumptions you're building into your code to make sure that they are good assumptions. So here I have the assumption of there is never going to be an owner with two pets with the exact same name. The other assumption that I am making here, the other sort of implied assumption, is that capitalization matters for pet names. Notice here, I'm just using equals. I'm not using equals, ignore case. I'm not doing a to lower before doing the equal. I'm just doing straight up string equals string. If there is a capitalization difference, you're searching for lowercase o Oreo instead of capital case O Oreo, this will fail. It will not work. So that's something that I should probably change. And I left this one in like this to sort of illustrate this is why you want to plan out your code and have a plan in place. Because I didn't have a plan in place. I just sort of had like, you know what? I think a pet, this kind of a demonstration worked well for object-oriented. Let's just get writing. And I went in guns a-blazing. And there's just, as a result, a couple of oddities did crop up. Most of them I fixed. A few of them I left in just sort of as demonstration points. This is one of them. I really should be accounting for lowercase and uppercase here, like using equals ignore case, to make sure that capitalization doesn't matter, because it shouldn't matter here. It doesn't matter whether it's capital O Oreo or lowercase o Oreo. The name is Oreo. That should find the pet. Now, these are the things you have to watch out for. Keep in the back of your head when you are writing code. And, again, ideally, planning your code out so that you think about these things before you write them. Because I would not have found this other than having to go back through and do this video. I would not have realized that I had this little ticking landmine here until all of a sudden I was failing to look up a pet name that I know should have worked. And then I would have eventually figured out, oh, it's because capitalization matters when it shouldn't. Continuing on. Add a pet. Oh, hey, here's the get pet by name. Here I am explicitly enforcing the rule that you're not allowed multiple pets. Again, is this a good thing to do? I don't know. If we were doing this for a client, this would, again, be the part of the reason why we do planning, plan everything out so we can go to the client. It's like, okay, we're not going to allow owners to have pets by the same name, and we're not going to do this, and we're going to do that. And then the salon can say, hold up, I don't like that. We should allow duplicate names. Or, yes, that's fine, great, do it. But here, we are saying, no, can't have two pets with the same name. And so I am getting the pet by name. So here's the new pet being passed in, grabbing its name, passing it in. Wait a minute, we're grabbing its name directly. We're not using the getters. We're not using get name. What? What's going on? All right, this is where we got to talk protected and some of the aggravations of Visual Studio Code. So if you read up on protected, which would have been part of the reading assignment from previously, it restricts access to the package plus inherited classes. By default, everything in the same folder is in the same package. So everything inside of here is the same package. That means if a variable is protected, everybody in this package can see it. And it has to be that way. Because watch what happens, and don't do this change, by the way, or if you do it, undo it. What happens if we change this to private? Kaboom! Many things break, including dog and cat. Because dog and cat are also using name. Now, this gets into a little bit of design philosophy for object-oriented programming. How much encapsulation should you be doing? Some encapsulation is good. Then, in fact, that's part of the point of object-oriented programming, is coming in and saying, I don't want random code messing with these values. I want to encapsulate them. I want to protect them. But you can't take that too far. Like, there are reasons. Like, in this particular case, having children classes have direct access to information that makes sense is something you very commonly do. So that's why you would actually use the protected keyword here. Another reason I would use protected is, like I said, this is a package. I could, instead of building this as a jar file, build it as a package and then use it in a different piece of code. And that code project would not be able to directly access these values. Not unless they had an inherited class. So there are reasons for doing protected, but you can't really see them in this example. Now, can we create our own packages internal within a project? Technically, yes, but Visual Studio is really weird about it, and so we will deal with that much later in the semester. For now, understand that the reason why owner can directly access the name of pets is because I have them marked as protected, which would be, in my opinion, the correct attribute to have, or the correct modifier to have on them instead of public. They're protected, but since everything's in the same package, owner can see it. Okay, continuing on. So I'm checking to see if the pet already exists. And if it's null, remember, if you use, like if I actually tried to use like .toString on existing, it would crash if it's null. No good. You can't use a null reference, but you can always check for null. That's fine. So if it is null, that means, yay, I didn't find it, so I will add the pet. Otherwise, I'm going to yell at the user, pet already is added. And then we have report all pets, which is interesting, because remember, this is of data type pet. Pet doesn't have toString defined. So what is this going to produce? We're almost ready to find out. Let's look at main, and then we can actually start looking at some output. So in order to create a pet, I need an owner. So I create an owner. Me equals new owner, name, Richard, address, Ohio. Yes, I know I'm revealing that I live in the state of Ohio. I'm sure I can trust you all with this information. Next up, I'm going to create some pets. And so we've got cat, Oreo equals new cat. Pass in the name, age, and the owner. And because I want the breed set, but I didn't do it in the method here, I'm going to have to call set breed and set color pattern to set those two particular values. Declare a cat frazzle without setting any breed or color pattern information. So that's going to be the default values of null. I mean, not null, unknown. And then, of course, we have a dog, Oliver, who is a schnauzer. I'm not entirely sure I'm spelling that correct. And there we go. Those are the pets. And then a generic pet that's there for demonstration purposes. And in case you're curious, yes, these are some of the pets I've had throughout my life and the ages at which they passed on. So let's see what happens. Let's get this code ran. So hit run there. And so let's take a look at this first block here. System.out.println on Oreo, Oliver, and pet. We'll do Frazzle later. So Oreo, Oliver, pet, and there we go. You get the expected results. Oreo is a cat and a Maine Coon and is 8 years old. They have black and gray fur. Oliver is a dog and a schnauzer and is 13 years old. Pet at garbled number thing. What? So this is basically a memory lookup. Remember, when you have a reference variable for an object, so pet here, and Oliver and Frazzle and Oreo, these do not contain all of the information, like the value, like the literal value being stored in memory for this variable is not the information for a cat. Instead, it's something like this, which is the memory reference code for where in memory those values are being stored. This is important to understand for objects. And if you don't define a toString and you call toString on a class, what it does is it defaults back to objects toString, and objects toString prints out this memory lookup value. Yes, there are things that you can do with this, but that's very advanced coding, and we will not be getting into that for this class. But because Oreo is a cat, we use the cat version of toString. Oliver is a dog, so we use the dog version of toString. All right, let's have the pets take a bath. Again, pretty much as expected. For the generic pet, we got not defined for a generic pet, because there it is. There's the version take a bath for pet. But because dog overrides take a bath, you get dog's version here. And again, because cat overrides take a bath, you get the cat version. Now we get to report all pets, and this is where things start getting interesting. The first time we call report all pets, we get this. The owner is Richard, they have 0 pets. But hold on, I've been assigned as the owner to every single pet that's been created so far. What's going on? Well, just because the owner class has the ability to store references to pets doesn't mean that those references are magically created. The fact that a pet has a reference to an owner doesn't mean anything's done to owner. You have to explicitly do that. Yes, I've been declared, there's an owner here, and yes, that owner's passed into cat, but nothing's done to this instance of owner. So while the cat knows it's owned by me, I don't know that I own the cat because this instance of owner has never been told that. And that's what we have in this little code block right here. I'm adding all of those pets to the owner. Now when we do report all pets, again, something interesting happens. Correctly says that we have 4 pets. Let's look at these toStrings. So remember, pet doesn't have a toString. The array list for owner is of data type pet. So every time I'm down here calling toString, I am calling toString on data type pet. So then why is everything reporting correctly, and the only time I'm seeing the weird code is for the pet that is a literal pet? This is the aspect of polymorphism for object-oriented programming. Again, part of why object-oriented programming is simultaneously so awesome and potentially absolutely nightmarish in order to maintain. A pet, the parent class, of course, I can store a dog in pet, I can store a cat in pet, but when you do that, that information is not lost. When I say add pet Oliver, and it's being passed in as a pet, not a dog, I'm not losing any of the information. It's still a dog. It's the memory location that this is pointing to is the memory location that has all the information for a dog. So I'm not losing any information. It's still a dog. And then what happens when we do the system.out.println pets.get toString, it's going, okay, what is this? And again, under the hood, there's a lot of magic going on under the hood here. Under the hood, Java's going, all right, I've got this reference. Is this actually a pet or is this a child of pet? Oh, this is a child of pet. So let me check, is there an override for the toString method? Oh, yes, there's an override for the toString method. So therefore, I am going to use the child toString. It's kind of the same reason why, toString works on pet. When you call toString on pet, it's like, well, it'll try to resolve, only resolves backwards. So, again, even though this is pet, if it's a dog or a cat or whatever that's been put in here, and that child class has overridden the string method, it's going to use the child class's version. Again, this is like the really awesome part of polymorphism. But there are limits to this. One final little bit before we talk about the assignment. Pet demo equals Oreo. No keyword here. No new keyword here. So what are we doing? Remember, the actual value of the variable Oreo is its memory location. Where in memory is the actual data for this instance being stored? So when I say demo equals Oreo, I am not creating a copy of Oreo. I am copying over the memory reference. So now both demo and Oreo are pointing to the same location in memory. This is critical to understand. I do not have two copies of Oreo. I have one copy of Oreo and two variables pointing to that information. And this is very easily demonstrated. I say demo.name equals Oreo the Great, but then when I call toString on Oreo, it says Oreo the Great. Demo and Oreo are pointing to the same location in memory. And just sort of to also further demonstrate, demo is a pet. But if we run this code, we still get the cat version of toString. Again, polymorphism. Demo is, again, magically under the hood. It's able to look at the data demo is pointing to and understand, oh, wait, the data that I'm pointing to is actually a cat. So I'm going to use the cat version of toString. Again, there's limitations. And this is where this little meow function comes in. So Oreo is a cat. Oreo can meow. There's a reason why I've got this line commented out. Because it doesn't work. Red squiggles of doom. Method meow is undefined for type pet. So there's a limitation to the polymorphism. Pet does not have a definition for meow. Nor should it. Right? That would not make any sense. So if I have an explicit data type of pet, and I try to call a method that only exists in the children, that will not work. I can't call set breed. I can't call set fur pattern, fur color pattern, none of that, because those are methods that only exist in the child. If I want to call those, it has to be done on an explicit data type of cat. The polymorphism only works when you've got the parent-children classes sharing the same methods. The child has overridden the parent's methods. That's when polymorphism works. Confused yet? It's a lot to take in, admittedly. Watch this video again. make sure you've read all of the W3 School reading assignments. Take your time with this. It's a lot to absorb. All right. The assignment basically is to make this Pet Salon class work. Do not change anything else. Do not change owner, pet, dog, or cat. Do not change those. What you need to do is down at the very bottom, there's these 4 lines of code. Uncomment them. And now make it work according to the instructions in Pet Salon. Again, you are not allowed to change these lines of code. You are not allowed to add to these lines of code. These 4 lines are to be left alone. The one change you can make in main, by the way, if you want to clean up your output, you can comment out, delete, whatever, all of this owner stuff here. This is just talking points for the lecture. They have nothing to do with the assignment. If you want to take them out via comments, delete it, whatever, that's fine. You want to leave it in? That's fine too. And the key part is that you have these 4 lines of code, you uncomment them, and you do not change them, you do not add to them. Going over the instructions. Point number 1. Make a default constructor that prints out when the class is created. If I come over here to look at my sample input, there we go. Salon created. Item 2. Create a function called setUpOwners. Inside this function, create 3 owners, each with 2 pets. There should be at least 2 cats and 2 dogs, with at least 1 Maine Coon and 1 Husky. All pets should have their breed, and in the case of cats, fur color set. So, you're creating a total of 6 pets. There must be at least 2 dogs and 2 cats. There must be at least 1 Maine Coon and 1 Husky. But beyond that, the other two pets, your choice as to whether they're cats, dogs, whatever mix you want to do there. The main thing, like I said, is I want to see those alternative bath messages. Create a function called reportAllOwners. This function will display the name of each owner, how many pets they own, and their pets' information. Print a separator in between each owner. I mean, sounds like we've got at least some of that already done, right? You know, the owner class over here has a report all pets. It sounds like that covers quite a bit. And as you can see here, yes, that's exactly what I'm doing. Again, you do not have to mimic this exactly. I mean, obviously, you're not allowed to change the report all pets in owner, so that part will be the same. But as far as like, pardon me, as far as owner names go, pet names, types, etc., your text does not have to match exactly. You know, you definitely do not need to copy all these names. That's not required. You can choose whatever separator you like. I just decided to go with this one. And then finally, function called bathe_all_pets. And it will call take a bath on every pet for every owner. So again, looking back over here, we have Buddy, Whiskers, Rocky, Shadow, Cooper, Mittens. And we got Buddy howls a song with people, Whisker deploys the murder mittens, Rocky, Shadow, Cooper, Mittens. Now everybody is there. So that is the assignment. Now, you can create additional functions. You are not limited to just those functions for your Pet Salon class. For reference, I did have one additional function. In my code for generating the sample output. It's not required. But if you want to have additional functions or spread the workload out, however you want to do it is fine, just as long as this code here works. If you have questions, message me on Blackboard. Otherwise, good luck and have fun with this.